Hey everyone, let's take a look at this one, number 18 in section 2.2, and it's a graphical example. Maybe a little bit hard to understand what's going on, but we're given the graphs of several functions, and we're going to use these graphs together with the properties of limits, the basic limit laws that we've learned, to evaluate basically the limits that are way down here at the bottom in the answer bank. And we're basically going to take these limits and drop them into one of these three options. So either these limits all down here will either equal -1, 2, 3, or they will not exist. Okay. So, and we've got, hopefully you can see the colors, blue function here, f of x. So notice there's a little hole here and a point down here in blue. So the actual value of the function at 4 is close to 4, right? The height of this dot, this point. The red graph here is h of x, a little jump in the graph here. And then this orange, I guess, color looking maybe is orange or brown. I don't know, y equals g of x. Okay, so let's just start with this expression here. What would the limit as x approaches 4 of -1/6 f of x be? Well, this -1/6 is a constant multiple. It can come out in front, provided the limit as x approaches 4 of f of x exists. So what is the limit as x approaches 4 of f of x? A minute ago, I told you the value of the function at 4 was equal to 4. Is that the limit of the function as x approaches 4? No. As x approaches 4, it's where are we going to on the graph? Where is the graph getting closer and closer to as x gets closer and closer to 4? Well, as we approach it from the negative side, from below, then we're going along this curve. As x is 3.9, we're up here, 3.99, we're up here, getting closer and closer to this hole, which has a y coordinate of about 6. So the limit from the left is going to be 6. So we approach 4 from above, from the positive side, from the right. We're coming down here. Again, we're approaching the coordinates of this hole. So again, the limit from the left and the limit from the right are both equal to 6. Therefore, the limit is 6. So even though the value of the function is down here at 4, the value of the limit is 6. So the limit is x approaches 4 of f of x is 6. 6 times -1/6 is -1. So it goes in that area. And this one we're approaching 4 from the negative side. You'll notice I usually just write the minus sign right after the 4. They do it as a superscript. It's kind of hard to see, so be real careful with that. And so we've got the limit of a quotient. So the basic limit law says we'll take the limit of the top over the limit of the bottom. And the limit of the top is the difference, right, of limits. So I take the limit as x approaches 4 of the negative side of h of x, and then I subtract the limit as x approaches 4 from the negative side of f of x. Okay, so what's the limit as we approach 4 from the negative side of h of x? Well, here's the function h of x. Here's 4 as we approach from the negative side. That's from below. We're on this red curve. We're getting closer and closer to what? This hole, which has a y coordinate of 2. Right? In fact, it's pretty constant, 2, 2, 2, 2, 2, going right to 2. So that value is going to be 2. What's the limit as we approach 4 from the negative side for the function f of x? Well, we already know that. We did that. As we approach 4 from the negative side, we're going right to this hole, which has a y coordinate of 6. So the top is going to be 2 minus 6, which is -4. And what's the bottom? The limit as x approaches 4 from the negative side of g of x. Well, here's g of x. So we approach 4 from the negative side. It looks like we're getting closer and closer to -2. There's no hole or gap or anything here, but so there's no mystery. We're actually going to the value of the function at 4, which is -2. Okay, so the top was -4. The bottom was -2. -4 divided by -2 is a +2. All right, as we approach 4 from the positive side, what's the limit of h of x? Well, h of x is the red graph. As we get closer to 4 from the positive side, we're going along this curve, and we're approaching closer and closer to that value of the function right at that point, which is 1, right? We're getting closer and closer to that point, which has a y coordinate of 1. So the limit from the right of 4 is 1. And what about h of x? H of x Oh, I'm sorry. I just did h of x. That's this part. Oh, I'm sorry. Jump to this one. Okay, so h of x we said was 1. And then what's the limit as we approach 4 from the positive side? Well, from the positive side, we're going this way, going right up here to this point right here, which is at -2. So I'm going to have 1 minus a -2. 1 minus -2 is 1 plus 2. That's equal to 3. Limit as x approaches 4 of g of x. As we approach 4 of g of x, again, from both sides, we're approaching -2. Again, the g of x, there's no mystery. There's no hole, gap, or anything. In fact, in section 2.4, we talk about continuity. If you haven't seen that video already, then we'll talk about the fact that this function is continuous everywhere. So the limit is equal to the value of the function at every point. And so the limit as we approach 4 from the negative or positive side, we're going right to that point, which is at -2. So that's -2. But here's the problem. What's the limit as x approaches 4 of h of x? Well, the limit we said from the left was 2. The limit from the right was 1. Since those two limits both exist but are not equal, therefore the limit as x approaches 4 of h of x does not exist. So we can go ahead and just stick this in or right in there, okay? Because that part does not exist. It doesn't matter what this limit is, right? The limit will not exist. Okay. Going here as we approach 4 from the positive side. All right, so I've got g of x and then squared. So what's the limit as x approaches 4 from the positive side? We can bring the limit inside the squaring function, provided the limit exists. And for g of x, we've already said that as x approaches 4 from the positive side. Coming from the right, we're getting closer and closer to -2, right, which is the point right there. So that's -2, but we're squaring that. That gives me 4. So this is 4. And then h of x as we approach 4 from the positive side, we're getting closer and closer to 1 again. So I've got 4 minus 1, that is 3. And then this one, the limit as x approaches 4 of f of x. We did that already in the before, right? As we approach 4 from both sides, we're going closer and closer to this hole, which has a y-coordinate of 6. So that's 6 plus 2 times g of x. And again, the limit as we approach 4 for the function g of x, right, from both sides, we're going right to that point, which has a y value of -2. Okay, so this limit here was, 6? And then 2 times the limit, -2, right? 2 times -2 is -4. 6 plus a -4 is 2. Okay, so hopefully I did my arithmetic in my head correctly. You might want to write this out in paper and just sort of keep track of what's going on. I didn't do that, but that would be a good idea. Let me just check the answer and see if everything's okay. All right, we got it down. Okay, so again, your graphs might look a little different, or these functions that you're plugging in here might be a little different, but this should be helpful for you. So hope this helps. And if not, as always, let me know.